Right, let's continue this Boggle word checker thing over here, which is right now it's apparently checking all of them, like chick like letter A, and I think the problem is that this always passes, but it shouldn't, because this says like y is -1 plus m and 0, and if it wants to do it over here, y -1, it's -1, it becomes -1, so it starts from over here, and that's the problem. It should just throw an error. It should have just thrown an error. So let's say what do we say? If x is less than 0 or y is less than 0, then just break the loop, or just like pass. Else do that, and I think we don't need this except loop. A, letter is A. And it's around E. L, A, L, N. Then it's R, A, C. R, A, C, S, I, A, L, A. It works great, it works terrific, and we don't need this try except block over here, I hope. Oh, we do need it. Alright, so if it is cool, try that. And here we do another thing. Here we do if new letter, if new letter equals to the letter, I think that's right. So the letter is A, and it is matching with this one. So if new letter is the letter, then we say first enumerate it here so you can call it, and do candidate index, and here we say if the new letter is the letter, we just say candidate, we just say candidates we got a dot append dot append this one dot append damn, this recursion thing, new letter is over there. I'll just do a new one. I just do a new one. So that's the new letter, and gotta check. If new letter is the letter, we say, oops, here say new coordinates equals that in the f string x and y, and then we do if then we have to do it if new coordinates in candidate pass, else we wanna do a new appendation where we say candidates append, and what do we want to append? We want to do oh, let's test it here. If we got A is, I don't know, C, D, F, G, and B is focus K, yeah, A plus B. Yeah, alright. Candidates dot append candidate plus new coordinates, and that should happen for every letter, for every candidate, and also when you are done with all the candidates. Alright, so we do that for every candidate, and here we need to go 4 back and to just say we got to remove the candidate that we are not using, or maybe not. So in the end, I say 1, 2, 3, 4. We say if length of any candidate is more than the length of the word. So then we do for candidate in, oh, we can do that. Oh my god, someone is messing with the mouse. No. And then after this we gotta do you gotta do I'm gonna check the candidate. So we say if candidate, if length of the candidate, if length of the candidate is the same to the length of the word, it's the same to the length of the word, just return true, else return not else, but in the end of the function return false. Well, I'm amazed. I guess there is a use for all these things that I did. Because the algorithm is okay, it's very long. I think this shall time out. It didn't. Local variable candidate reference before assignment. I need timed out. I guess that's the problem. But yeah, it's funny, man. I guess it's like really long. This thing. It should. So. Return else, and I think it should like remove it. Alright, so you got this interesting algorithm that we made that just currently is not appropriate for like it's not it's not finished, in other words, but I'm actually pretty proud of it that it worked. And we can also fix quickly this thing over here, because it doesn't solve it for one solution. And here we do just if length of the word equals Anna. I can do it just right over here. If length of the word equals 1, just return true. And now all of the tests here shall be green, but all of the later tests, I guess, maybe there is something wrong. Maybe there's something else wrong, or maybe now it is just the problem that the algorithm takes too long to run. See, because we still got failed, 21 failed, and I don't know why. It says true should equal false, false should equal true, and this is on grid of 5 times 5. It's the problem also in 7 times 7 and to random tests. And that, alright, so you got here letter is, you got, so thumb down, so it's thumb down, so you got INGL on 5 times 5 grid, something is wrong, alright. And now we got this bamboozling thing, because it is why come on, what? Now you got this a little bit hard to debug, if you know what I'm saying. So here it says false should equal true. All right. All right. So is there anything we can do to make it run faster, to make it not time out? Well, we could remove the old candidate once we run through it. So every time we check if the candidate is the length of the word, and also how do we remove, like Python remove from list an item from list, remove method, remove object. This is the object to be removed from list. Alright, so we wouldn't actually need an index, we just say candidates dot remove, it's remove candidate. Now nothing, okay, list dot remove x is not in list. Oh, because this should be over here. Okay. If length of the candidate, so I don't quite understand this, because this is now length of the this shall be red, I guess. Yes. If we just comment this out, put it up there. Okay. So now it's green. Now we got a lot of less failed ones. That is interesting. I think we got some stroke of luck helped us over here. So let's just remove the so here's the problem. We got candidates dot remove the candidate, and then we get errors if we remove the specific candidate. Candidates append new coordinates. Remove from list by index. Del. Here is the del statement. To remove a given instead of its value. Differs from pop, which returns the value. Del statement can be used to remove slices. So just del a something. Alright, so we do del candidates cand index del, and we delete it. And it's not good. False should equal true here. And if we delete this, I have, like, this is the first time in my life I use this del thing. Like, why does it alright. Right, so I got this idea, because here you go for every candidate, you go through all of the adjacent elements, and here we shall say worthy, and it's false at first. And if new letter equals letter, we set worthy to true. And after every this, we say if length candidate is length of the word, return true. Elif worthy equals false, then we delete it. And this should not work, and this should work now. Oh. Oh.
Yes,
this is not working. Alright, so where are we at? Yeah, so this is really confusing. I do not know why it does not work if we delete the currently used thing. And yeah, it is really confusing. So yeah, let's just Baylor, and the letter is, oh, so this is up, Euler, and for we do can we just, after we're done with this so-called candidate, we just print candidate to see what that looks like. The 3, and here is just 1 2 1 2. And that's it. And if we don't delete it, we get a lot more stuff. So we do not want to delete it. We get lots and lots of, oh shit. Oh fuck. It's lots and lots of stuff, you know. So now because you would think if the candidate does not work in every direction, then we should like remove it, you know. And it's a hard one, and I think exit code, is it, oh, it's just maximum size reached. That's the problem. That's really like long, really a lot. If I make an attempt with that, So what the heck is going on? No. So we still get timed out. Yeah, exit code 1, I guess. So, So, were they true? Candidate. For every letter, check every candidate. So, but here the problem is true should equal false. Alright, so here we say what do we do? Print original word is, and here we do word, then we do for line in board, we just print line. Okay, see what's wrong here. Of course we shall reach like the maximum thing. I don't know, like apparently I do not even know how this logarithm works. So yeah, animal sla true should equal false. Now what happens here? Animality anaima, and it just goes through letters. It should go through letters. Alright, like I don't know for which one is this wrong, but this is G C L A A, and here you go animal. It doesn't go until the end, and that is just so funny, you know. Should do it like so then. And then if candidates, the last element, its length equals the length of word, then return and return true. And it's all green. And here, what shall we get? Here. Oh, we get even more wrong ones. Oh no. Animal. And it doesn't even get to the ITY. Mingle, it doesn't even get to the E. So weird. true should equal false. And so we say just print candidates -1 to see what happens. And of course we have to wait like 12 seconds now. It's not that big of a problem. And yeah, animality. So 4 4 1 0 1 2 3 4 0 1 2 3 4 ni ma, and then it picks up anima. It just takes 4, this, and then 1 2 0 1 2 3 and 0 1. This is anima. It takes 2 A's, and it shouldn't take 2 A's. It says if a new letter is the letter. So let's say anima, then it goes anima 2 animali to y. Okay, what it does is it's alright, so this is the reason why this thing doesn't work, is because it takes stuff that it shouldn't take. Because here we get a bunch of A's. Animal. We get a bunch of A's. We got like, this is an A, this is an A, and probably this is an A, because we got A. So what's wrong? We do for element in the adjacent elements for candidate and enumerate candidates. Yes, so that's problem. I'm gonna finish here to continue the second one.